Today, balancing redox reactions in acidic solution. You can also balance redox reactions in basic solution, but there are a couple extra steps. Acidic solution is easier. What I need you to remember is that the electrons gained in one half of the reaction have to be the same as the electrons lost in the other half. You can't create or destroy electrons. There has to be a balance. See? Balancing. Electrons gained has to be the same as the electrons lost. I'll show you how to do that. Once you've had a balance of electrons gained and lost, all you're going to do is add H2O to whichever side doesn't have enough oxygen. And then you're going to add H plus to the side that doesn't have enough H. We're adding H plus because it's acidic solution. And H plus is what makes solutions acidic. Let me show you how it's done. I want you to balance this reaction. Chlorate plus iodine makes chloride plus iodate. First things first, assign oxidation numbers. Oxygen's always -2. That contributes -6. The total charge is -1, so the chlorine has to be +5. This is elemental iodine, so the oxidation number is 0. This is chloride with a charge of -1, so the oxidation number is -1. And in here, oxygen is always -2. That contributes -6. The total charge is only -1, so we need it to be +5 here. Okay. What do you notice about how the oxidation numbers changed? Chlorine went from +5 to -1. It decreased by 6. How do you add 6 negatives? That's adding 6 electrons, because electrons have a negative charge. Here's what I propose. ClO3- and 6 electrons combine to form chloride. Notice the oxidation number went down 6, so we had to add 6 electrons. Now, iodine goes from 0 to 5. Here's a small trick though. There are 2 iodines here. 2 iodines, and each of them has an oxidation number of 0. We're going to need 2 iodines here, so we're going to have to put a little 2 in front here. And each one is losing 5 electrons because the oxidation number is rising by 5. So, an I2 will break up to produce 2 of these IO3-. See, we have 2 iodines and 2 iodines, and each iodine is going from 0 to 5. Losing 5 electrons. There's 2 iodines, so in total, you're losing 10 electrons. 0 to 5, and there's 2 iodines. That's where we get the 10 from. Unfortunately, this reaction gains 6 electrons, and this reaction loses 10. So, how do you balance those? Well, what's the lowest common multiple between these two? You can choose 60, but you can also choose 30 because 6 divides into 30 and so does 10. Here's what I propose there. If you multiply this by 5, you get 5 ClO3-, 30 electrons, and 5 Cl-. Notice how we just multiplied them all by 5? We want this to be 30 as well, so we multiply each of those by 3. 3 I2s, 6 IO3-, and 30 electrons. Notice now that in this reaction 30 electrons are gained, in this reaction 30 electrons are lost. When you add these two together, the electrons cancel each other out, and you're left with 5 chlorates, 3 I2s, combining to form 5 chlorides, and 6 iodates. Notice now, 5 chlorines on this side, 5 chlorines on that side, 6 iodines on this side, 6 iodines on that side. Oxygen is not balanced yet. Charges are not balanced yet. That's what the extra steps come in for. Where are they? We've got to add H2O to whichever side doesn't have enough O, and add H plus to whichever side doesn't have enough H. So, it's party time. Let's do this. I got 15 oxygens on the left. I got 18 oxygens on the right. So I need to add 3 to the left-hand side. How do you add 3 oxygens? You've got to add oxygens by adding water. See, 3 oxygens. And 5 chlorates and 3 iodines make 5 chlorides and 6 IO3 minuses. So now I've got 3 and 15 is 18 oxygens on this side and 18 oxygens on that side. Oxygen's balanced. The last thing we do is balance the H's by adding H plus. Notice I have 6 H's on this side, and I don't have any on this side. I need 6 H's on this side, and I add them by adding H plus. What you'll notice now is that it's completely balanced in every way. 6 hydrogens, 6 hydrogens. 18 oxygens, 18 oxygens. 5 chlorines, 5 chlorines. 6 iodines, 6 iodines. And even the charges are balanced. The total charge here is -5 because there are 5 ions that have a -1 charge each. Here we have 5 ions that have a -1 charge each. We also have an extra 6 ions with a negative charge and an extra 6 ions with a positive charge. Those charges kind of cancel each other out because there's 6 positives and 6 negatives. 5 negatives on this side, 5 negatives on that side net. Boom! Charge and mass balanced. This is the balanced redox reaction, and you know it's in acidic solution because there's H plus, and H plus is the hallmark of an acid. Now you can balance your own redox reactions. Best of luck.